Question 7a, Part 1. Use differentiation from first principles to show that the first derivative of x equals 1. Differentiating x by first principles, we have the limit as h approaches 0 of x plus h minus x over h. Now expanding the brackets and simplifying the numerator, we have x plus h minus x, the x and the minus x cancel, and that equals the limit as h approaches 0 of h over h, which equals the limit as h approaches 0 of 1, and applying the limit, that equals to 1. Part 2. Use mathematical induction and the product rule for differentiation to prove that the first derivative of x to the power of n equals n times x to the power of n minus 1 for all positive integers n. The first step is to show the statement is true for some value of n, and in this case, the smallest value of n that we can test is n equals 1. Now the left-hand side of the statement is equal to the first derivative of x to the power of 1, which equals 1, and this was proven in part 1. And the right-hand side of the statement is equal to 1 times x to the power of 0, which also equals 1. Now the left-hand side equals the right-hand side, hence the statement is true for n equals 1. Next, we assume the statement is true for n equals k. That is, the first derivative of x to the power of k equals k times x to the power of k minus 1. Next, we show the statement is true for n equals k plus 1. Now from the left-hand side of the assumption, the first derivative of x to the power of k plus 1 is equal to the first derivative of x times x to the power of k, which equals to the first derivative of x times x to the power of k plus x times the first derivative of x to the power of k, and that's by the product rule, which equals to 1 times x to the power of k plus x times x to the power of k minus 1. And this is from part 1 and the assumption, which equals to x to the power of k plus k times x to the power of k minus 1, which equals x to the power of k plus k times x to the power of k. And factorising out x to the power of k from both terms, that equals to k plus 1 in brackets times x to the power of k, which equals n times x to the power of n minus 1, since n equals k plus 1, which equals the right-hand side of the original statement. Therefore, by the principle of mathematical induction, the statement is true for all positive integers n.